Okay, let's dive in. Today we're going to try and unpack Docker and containerization.
Yeah, it's a big topic and a really important one.
It really is. It feels like the engine behind so much of modern software. And our mission here is really just to cut through the jargon.
And get to what actually matters.
Exactly. So where do we start?
Well, the core idea is all about efficiency through isolation. Containers are these lightweight, portable packages.
Right, they bundle everything up.
Everything, your application, all its dependencies. And what makes it so powerful is that they share the host operating system's kernel.
Which means they're consistent.
Unbelievably consistent. It runs the exact same way on your laptop as it does, in the cloud.
And that consistency, that's the holy grail for any developer, right?
Absolutely.
So to get there, we have to start with the most basic vocabulary. The first thing that always seems to trip people up.
The difference between an image and a container.
Yes. What is the actual difference?
I always like to use an architectural analogy. Think of the Docker image as the blueprint for a house.
Okay, the blueprint.
It's a read-only template. It has every instruction, every layer needed to run the software, the code, libraries, runtime, all of it.
So it's static. It doesn't do anything on its own.
Exactly. The container, on the other hand, is the actual live building constructed from that blueprint. The image is inert, the container is active.
That makes perfect sense. So how do we create that really reliable blueprint in the first place? That's where the Docker file comes in, I assume.
Precisely. Instead of you manually configuring everything and risking mistakes, the Docker file is just a script, an automated step-by-step recipe.
A recipe.
It builds the image, guaranteeing that reproducible consistency we were talking about. It really is the source of truth for the environment.
And what's fascinating there is the speed advantage that must give you.
Oh, it's huge.
Yeah.
Because it's automated, development workflows just accelerate like crazy. Think about continuous integration. Just knowing your build process is identical every single time saves countless hours of debugging those it works on my machine issues.
The classic problem. So speaking of workflow, what about complexity? I mean, a developer is rarely running just a single service.
Almost never.
You've got your database, a backend, maybe a separate cache. How do you manage all those pieces together easily?
And that is the exact problem that Docker Compose solves.
Okay.
It shines when you need to coordinate several connected containers. Instead of running 3 different long command line instructions, you define the entire architecture.
The whole thing.
The whole thing. Your application services, networks, volumes, all of it in a single, simple YAML file.
So you're up and running in one command.
One command. It's a monumental improvement.
Which brings us to, I think, the crucial comparison from our source material. Containers versus virtual machines, VMs. Why are containers so much faster and lighter?
It all comes down to resource utilization. A traditional VM needs its own full operating system, a guest OS.
Right, with the hypervisor, everything.
Exactly.
Yeah.
All that massive overhead. Containers,
Yeah.
they just skip that. They share the host OS kernel.
So there's no redundant OS.
None. And that fundamental difference means containers boot in milliseconds, use far less disk space, and consume minimal RAM.
Which makes them way better for things that need to scale quickly, like e-commerce or microservices.
Vastly superior for those environments.
So what does this all mean for someone listening? We've covered the core structure. The image is the blueprint.
And the container is the running building.
The Docker file is the recipe that guarantees reproducibility.
And Compose is the tool that helps manage complex multi-container setups.
And the bottom line is they beat VMs on performance.
Mastery of these concepts is just.
Yeah.
It's essential now. Organizations rely on this efficiency. If you understand containerization, you understand modern infrastructure.
So given that, here's the final provocative thought. Everything we've discussed today handles isolated single-host environments. How might learning to manage critical data persistence using something like Docker volumes and then integrating with full-scale orchestration tools like Kubernetes, which manage hundreds of containers across many machines, how might that fundamentally change the way you approach building and scaling truly global applications in the near future?
That's the next step.
Go explore that.